Hi. This is not really a talk, more of like a show and tell. I just want to kind of show you something that I made over the past month or so. So if you remember last year's lightning talk about Checkasm, you'll be familiar that Checkasm is a tool that's used internally when developing projects like FFmpeg, X264, and so on. That helps you verify the correctness of your SIMD assembly. And also it's used for like performance benchmarking and profiling stuff. And one of the problems we had is that it was the sort of file that everybody just copied around. So you had a David version, an FFmpeg version, an X264 version, and they were all like wildly different, different licenses, different feature sets, different bugs. And so I got the idea, well, it was a long-standing idea in the community that what if we took all these Checkasm implementations and sort of unified them into one thing that can be reused across projects. So I did exactly that. I started to host it on Videolan, so I'm just going to kind of give you a quick idea of what it can do. So I basically took the single checkasm.c mega file and sort of split it up into your like platform-specific code goes to the platform-specific directories, and it's like all the performance benchmarking stuff is split off from the main function and so on. So I spent a lot of time trying to sort of clean it up and make it reusable, and I added like a public API so that if you're writing a project, I can give you a quick look of like just roughly what that looks like. Oh my god, no, that's not what I wanted to do. Sometimes I really hate and get I have to click here, of course, to go back to the root. So basically, it's a pretty simple public API because I decided like a lot of. So the problem with Checkasm is that a lot of the code is like slightly different between projects because you need to integrate your project-specific CPU flags, your project-specific like test that you want to run. So I created a new public API, which I tried to make hard to be backwards compatible with the existing Checkasm tests. So you just have your sort of like you define your CPU flags in a way that's just an API now instead of hard coding it in the specific checkasm.c file. And then you can just call the checkasm main function, which does the rest basically for you. And I made it, for example, a lot of architectural improvements are going on behind the scenes, like it's now thread safe. It's like, it'll work automatically in more configurations. So for example, you don't have to manually choose which performance backend do I want to use. It'll just sort of detect at runtime what's available and then pick the best one for the job. I spent some time improving sort of the terminal output, like if we're being naughty and sort of flipping some bits and some matrices, you can see that like, it has colors now, like what more features can you ask for? Like if you have these gigantic functions that output thousands of lines, now it's like a bit more manageable. You have line numbers and color printout and so on. So I tried to make the user experience a bit more manageable. And lastly, what I spent a lot of time on actually was improving the internal benchmarking. So if you saw my graphs from yesterday's presentation, that was all from Checkasm. So you have this sort of HTML output option, JSON output option that like has all the raw data, so you can really get an idea of like what is being benchmarked, how well is it being benchmarked, and the goal was sort of to try and make the runtime as low as possible. So whereas if, for example, you ran it on all of David, like a full bench run would take several minutes, even on my like quite powerful workstation. And now you can first of all choose how long should it run. Like you can say, oh, I want to run it for 20 seconds and just get the best data you can in that budget. Like by default now it runs in about 20 seconds for me, the entire run, instead of like 5+ minutes, while still being like more accurate because all of the like statistics going on in the background is trying hard to like extract the best signal possible from the noise floor. It's also kind of interesting because you can sort of see what's going on a hardware level sometimes. I'm not sure if I can find a good example on the fly. I maybe should have rehearsed in advance, but like sometimes you can see where you have this graph of how many CPU cycles per number of iterations of the function, and sometimes you can see that it like jumps from one performance regime to another performance regime, like because of CPU thermal throttling or whatever. So it kind of gives you a bit more insight on what's actually going on in the functions and how many cycles is it actually taking. So yeah, that's what I spent the bulk of the work on improving, like just the statistical robustness and the reporting and the user friendliness and the cross-platform support. Shoutouts to Martin for helping me with all the ARM stuff. That goes way over my head. So yeah, I kind of wanted to show you that it's a thing that you can use now. I guess we can also take a very quick look at how you would actually use it, because I'm sure that's interesting for especially people who are not already familiar with it. We'll take a quick look at what it looks like in the David fork that I use. So you have your tests that you still define yourself. You have your CPU flags that need to come from the project themselves still, so you still have to have this table that's already in most Checkasm versions. The main function, as you can see, like, it's trivial because all the code was moved to the library. And then you just write your individual tests. So I spent a bit of time sort of making these helpers nicer to use, adding like a lot of automatic overflow checking to buffers and so on, so it catches more bugs. And one of the things I still want to work on improving is I want to make it better at like finding buggy paths automatically. Like I want to add a bit of like generation of random buffers in a way that tries to find pathological paths, you know, sort of like a fuzzing architecture. So yeah, there's some ideas I still have, some improvements you can still definitely make, but well, it's a thing that exists now. If you're writing new SIMD, please consider using it. If you have an existing project, let me know if you're able to convert it to the new architecture. I'm currently converting FFmpeg, which is pretty straightforward. I'm also trying to convert X264, which is more involved because that was using like an ancient version of Checkasm. So yeah, that's all I had really to show you today. If you have any questions, feel free.
So you submitted a patch to David to convert that. Should I assume that that's sort of experimental and you want us to hold off until you've converted, say, FFmpeg also?
So I guess the question is, like, when do I stop calling it experimental?
Sure.
My plan was I want to target 3 projects, currently David, which is the trivial case because I use the David Checkasm as the basis. I want to target FFmpeg and I want to target X264, and if those 3 projects are successfully working on the new API and so on, then I'm going to release version 1 and start caring about stability. So, yeah, Kieran.
Have you considered doing, like using compiler, the built-ins to do as like a simple CPU flags test? I appreciate they're not as good as the FFmpeg or David ones, just to give the user something. I don't know what the right answer is.
So I guess the question is how do we want to start adding CPU flag detection to Checkasm, or like what is the use case? So, well, internally Checkasm doesn't really care about CPU flags at all because it sort of assumes the user is going to define the matrix of tests to run. It cares a little bit in the sense that it needs to know internally, are we going to care about, for example, checking V0 upper or not? Like it has some CPU-specific awareness. I mean, that code is kind of just ported from David, so there's some like internal checks to see if the CPU supports this architecture set or not. I don't currently have any plans on exporting any of that to the user, because I think that most projects that need this, they need it at runtime and not at test time, and I don't want to make Checkasm at runtime dependency, so the projects kind of have to need their own CPU flag detection anyway, so I don't really care about it too much.
There might be some value in having
to move on. Well, feel free to ask me in the break.